Carbon-12 and carbon-14 are both isotopes of carbon. A carbon atom has 6 protons and electrons in its nucleus, and both carbon-12 and carbon-14 have 6 protons. However, they are distinguished as different isotopes due to their differing numbers of neutrons. The key difference lies in the number of neutrons. Carbon-12. Carbon-12 is the most common isotope of carbon and consists of 6 neutrons and 6 protons. It is a very stable isotope and makes up the majority of carbon on Earth. Carbon-14. Carbon-14, like carbon-12, has 6 protons but has 8 neutrons. It is a radioactive isotope, meaning it emits radiation and is unstable, with a half-life of approximately 5,730 years. Carbon-14 isotopes are continuously produced in the Earth's atmosphere and absorbed by organisms during respiration and consumption of food. While an organism is alive, it maintains a constant ratio of carbon-12 to carbon-14. However, once the organism dies, carbon-14 begins to decay, emitting radiation and causing a change in the ratio of carbon-12 to carbon-14. This property is utilized in carbon dating. Carbon-14 dating is an important tool in the fields of geology and archaeology, used to determine the age of organisms. By measuring the changes in the ratio of carbon-12 to carbon-14, scientists can estimate the time of death of organic materials and determine their age. Isotopes are different forms of an element that have the same atomic number of protons in the nucleus, but different numbers of neutrons. As a result, isotopes of an element have different masses, and they appear at different positions on the periodic table due to their varying atomic masses. There are many elements in the periodic table that have isotopes. Some examples of elements with notable isotopes include hydrogen. The most common isotope is hydrogen-1, H1, but isotopes like hydrogen-2, H2, and hydrogen-3, H3, also exist. Helium. Helium-4, He4 is the most common isotope, but helium-3, He3, is another existing isotope. Oxygen. Oxygen-16, O16, is the most abundant, but isotopes like oxygen-17, O17, and oxygen-18, O18, also exist. Carbon. Carbon-12, C12, is the most prevalent, but isotopes like carbon-13, C13, and carbon-14, C14, also exist. Uranium. Uranium-238, U-238, is the most common, but isotopes like uranium-235, U-235, and uranium-234, U-234 also exist. Many other elements have isotopes, and each isotope is studied and utilized in various fields based on the specific characteristics and applications of the element. Isotopes have diverse applications in nuclear power generation, medical radiation therapy, isotope labeling, and other areas due to their nuclear stability and characteristics like half-life. That's correct. Isotopes refer to different elements that have the same number of protons, atomic number, but different numbers of neutrons. Elements are defined by their atomic number, which represents the number of protons. However, isotopes of an element have the same number of protons but different numbers of neutrons, leading to different masses. Isotopes of the same element share similar chemical properties but may exhibit slightly different physical properties due to their varying masses. They appear at different positions on the periodic table. Isotopes can occur naturally or be artificially synthesized. Due to their nuclear stability and characteristics such as half-life, isotopes find diverse applications in various fields. Examples include radiation therapy, medical imaging using radioactive isotopes, nuclear power generation, and applications in chemistry and geology research.